Hi everyone, welcome to GoClasses. Okay, Sandeep is saying that I feel like I come to movie theater with ads before. So yeah, little bit advertisement we have to do because once we start the lecture, we don't waste your time by advertisement, right? So you will never see that once we start from the starting till end, we only study. Okay, we never do any advertisement promotion. Okay, nothing. So basically we don't want to waste your time. Like it's not like we are teaching for 1 hour and half almost half hour we are only doing the advertisement promotion. No, that doesn't happen in go classes. Okay, so we only do the promotion only for maybe 1 minute. Okay, max. That only in the beginning. Okay, not in the middle. So let's start now. So today we will start graph theory, and this is very important subject. So let's see. First of all, let me tell you that if anyone asks me what is the most important chapter in GATE exam, okay, that is graph theory. That is graph theory. This is very important. This is extremely important. Like this is not normal important. This is extremely important because let me tell you that in GATE exam, if you notice, in GATE exam, from this graph theory, a lot of marks come. Only from this graph theory, only from this graph theory, you will get at least you will get maybe 3 or 4 questions. Okay, so these many questions, like this graph theory is used in all other subjects. This graph theory is used in algorithm, data structure, okay, like operating system, compiler design. You just mention the subject and this graph theory will be used. So this is very useful. This graph theory, this is a very useful area. This is a very useful field of mathematics, and this is used in this has many applications, this graph theory. So that is the reason from graph theory at least 3 or 4 questions you will find in the GATE exam. That automatically means that almost 4 to 6 marks you will get from this graph theory. And let me tell you that in 2022 GATE, in 2022 GATE, from the graph theory only, there were almost 4 to 5 questions. Almost 4 to 5 questions only from graph theory. Only from graph theory. Almost from this graph theory only, you had almost 6 to 7 marks. So this chapter, only this one chapter, this has very importance, great importance in the GATE exam. Okay, so this is very important. Now we will see why this is very important. This is very important for computer science. If you are a student of computer science, if you are not preparing for the GATE exam, then also you should study graph theory. Every computer science student should study graph theory. Okay, whether you are preparing for GATE exam or not, whether you are preparing for your interview, whether you are preparing for your company, this graph theory is really very important. Okay, now let's start and let's see what is a graph. Like what is graph in graph theory? So you have seen this type of graph, yes or no? In a school, we have seen this type of graph. We have seen this type of graph. We have seen this type of graph. Is this what we will study? We are going to study this type of graph? No, this is not what we are going to study. We don't study these graphs. These graphs are basically called plot, I can say. Basically, you have some data and you are plotting that data. Okay, so this type of graphs, if you notice, this type of graphs are called plot. This type of graphs we will not study. Okay, so what we will study? For us, this is a graph. Okay, this is what we will study. Basically, we will study some dots and lines. This is a graph. For example, here on the screen, you can notice there is a structure. This structure is basically, in this structure, can you notice what we have? Just notice what we have in this structure. In this structure, we have some node. So, okay, so this is a node. For example, this is also a node. And in this structure, like if you have these two nodes, 1, 2, these are the two nodes, and this is a line. This is a line which is connecting these nodes, correct? So basically, for example, this node 4, node 3. So you have two nodes, and this is a line which is connecting 4, 3. This is a line. So this is the idea. What is a graph? In graph theory, graph is just some dots and lines which are connecting these dots. So for example, these are the dots. Okay, total 6 dots we have. I can say total 6 nodes we have, or I can say dots we have. So these are the dots, and Okay, these are the lines. These are the lines which are connecting these dots. This is a line which is connecting these dots. Okay, so tell me how many dots we have, like how many nodes we have, number of nodes in this graph, number of nodes. So total 6 nodes we have. And what is the number of lines? Another name for line is edge. This, okay, this line, this is called edge. So how many edges we have? Number of edges. So you can notice that 4, 5, 6, 4, 5, 6, 7. Total 7 edges we have. So this is a graph in graph theory. In graph theory, every graph will look like this. So every graph is a structure with dots and lines. You can notice whatever graph you see, this is a graph. In this graph, you have dots and lines. So these are the dots, A, D. And this is a line which is connecting these dots. Similarly, here, these are the dots. And this is a line which is connecting these dots. So in graph theory, graph is a structure which has dots and lines. These lines are used to connect the dots. Okay, so very simple. So this is the simplest definition of graph. If anyone asks you the simplest definition, then this is the simplest definition. That graph is basically some dots, or I can say nodes, and some lines which are connecting these dots. This is the definition of graph. This is a very simple definition of graph. Now, why we study dots and lines? Like why they are interested? Why they are interesting? For example, what I will do if I study this structure, these dots and lines. If I study this, then like what I will do with this? Why we study dots and lines? Why we study graphs? Because graph is nothing, some dots and some lines which are connecting those dots. So why we study these graphs? So what is the reason? So can anyone tell me like why we are studying, why you are studying graph, why you are studying graph theory? Can you tell me? Can anyone tell me? The very simple reason, because it is in the syllabus, right? Okay, so that is the reason we study. Yeah, right? Yes or no? Because it is in the syllabus, so you are learning graph theory. Okay, now anyway, let's see some other reasons. Let's see why scientists, mathematicians, why they study graph theory. What is the reason why they study graph theory? So let me start with some questions like, so tell me, your assumptions, you have some assumptions, right? Do they reflect reality? Do your assumptions reflect reality? For example, all of us, every one of us have some assumptions. For example, we have some assumptions like, okay, that person is bad, that person is good, that party is good, okay, that party is bad, that party is very bad for our country. Okay, so those people are bad, those people are good. So this type of assumptions we have in our mind. Do your assumptions reflect reality? Okay, so let me take first example. With examples, I will explain that this is not the case always. Okay, so let's see examples. So this is your scenario one. This is your example one. What is this example? This is a question like, okay, many times people wonder about this question, right? Many times, okay, when you are sitting with your friends and then you are discussing this, okay, like this is the question. For example, on average, who has more opposite gender partners, men or women? Like, what do you think? What is your perception? Just tell me what is your perception. Like, I just want to know your perception. Okay, like please just tell me your perception. Because see, let me tell you, this is the question with which this MIT lecture starts. So this MIT course on graph theory, it starts with this question. This is the question that they start the graph theory with. So you can notice. So anyway, what is your perception? If you ask this question, if you go to people, okay, if you walk on the road and you ask random people about this question, like on average, please notice this, on average, who has more opposite gender partners, men or women? Then what people will answer, okay, based on their assumptions. Okay, note that people will answer based on their assumptions. Okay, for example, some people will say woman, some people will say man. They don't have facts, they have assumptions. Their answer is based on assumptions. Their answer is not based on facts. Yes or no? Agree or not? Like you are saying your answer. Some people are saying woman, some people are saying man, but your answer is based on your assumptions. That is not based on facts. Now let's see what are the facts. So this is the question: who has more opposite gender partners, men or women? And let me tell you that on this question there was a research. Many research have happened on this question. For example, the University of Chicago. Okay, this University of Chicago conducted a research to answer this question. This was the question, and to answer this question, University of Chicago conducted one research. So there were almost I think 3,000 people. Okay, on 3,000 random people, they conducted a survey, and they basically found some answer, because they wanted answer for this question, like on average, who has more opposite gender partners. So you can notice a lot of research has gone. For example, this ABC News also has conducted similar type of survey. So basically, okay, this type of research goes on many times. So it takes money, right? Yes or no? It will take some money. It will take like some amount of effort you have to spend. So that is the point. But if you know graph theory, then you can answer this question very easily. Let's answer this question using graph theory. Okay, using graph theory, you can answer this question very easily. You can answer. So tell me, let me randomly take, like I will not take exact data, but I will tell you some idea. So tell me, who are more, men or women on earth in India? Okay, which population is more, men or women? So you can notice that men population is more, right? Okay, so let me take 4 men, and let me take, okay, so let me take 4 men. Let me take, for example, 4 men I am taking A, B, C, D, and let me take 4 women like P, Q, P, Q, R. Okay, so these are the women. Now these are the men, these are the women, because you know why I am taking this data. I am taking this data because men are more than women. Okay, now tell me, now in this situation, I want to find out on average, I only want to find out average, on average, who has more opposite gender partners. Now tell me, if A is partner of P, then can I say P is partner of A? Tell me. For example, let's assume they are partner. Let's assume A comma P, they are partner, right? If A is partner of P, then automatically P will be partner of A. So this is the idea. Now let's assume, okay, so at this point of time, okay, how many partners A has? In this situation, for example, let's assume this is the situation. In this situation, who has more partner? In this situation, who has more partner? Like, tell me, how many partners for A? How many partners for A? There are 2 partners for A. And how many partners for P? 1. How many partners for Q? 1. So, okay, what do you think? You might be thinking, what is going on in your mind? In your mind, it is going on that, okay, A has 2 partners, so A is not loyal, right? A is definitely not loyal. But you can notice P comma Q, they are loyal. Now, tell me, who has, on average, men have more partner or women? At this point, who has more partners, men or women? At this point, what are the total number of, okay, so on average, please find the average. On average, who has more partners? So you can notice that the total number of partners men have, like I can say total number of partners men have is 2, and total number of partners women have, that is also 2. Because if A is partner of P, then automatically P is partner of A. If A is partner of Q, then automatically Q is partner of A. So total number of partners men have, opposite partners men have, that is 2. What is average? So tell me from this, what is average? Like average number of partners. This is what we want to find. What is the average number of partners men have? What is the average number of partners for men? Okay, men have. What that will be? That will be 2 divided by 4. And what is average number of partners women have? Average number of partners. Just find the average. So average number of partners women have, that is 2 by 3. Who has more partners on average? On average, who has more partners? So on average, if you notice, women has more partners. On average, you can notice that women have, on average, women have more partner than men. So tell me, okay, tell me from this, can you notice one thing, why this is happening? Can anyone tell me why this is happening? Like on average, you can notice that women have more partner than men, because there are more men, because there are less women. It has nothing to do with their partnership. Like, okay, it has nothing to do with their loyalty. Yes or no? You can notice in this scenario, women are more loyal. In this scenario, man is not loyal. But but still you can notice average number of partners for men, that is less than average number of partners for women. And the reason is very simple, because there are less women, there are more men. Now, okay, now the same. So let's do this. Let us assume that this Q and B, they are also partner. Let's assume this Q and C, they are also partner. Let's assume this Q and D, they are also partner. Okay, so something like this. Now, in this scenario, tell me how many partners for Q? How many partners for Q? So in this scenario, there are 4 partners for Q. There is 1 partner for B. There is 1 partner for C. There is 1 partner for D, and there is 0 partner for R. So tell me total how many partner this like men have total. So you can notice that is 5, and total number of partners women have, that also will be 5. Will it always be same? Like these two numbers, will they always be same? These two numbers, they will always be same, right? Because if A is partner with P, then automatically P is partner with A. Okay, so that is the idea. If Ranveer is partner of Deepika, then Deepika is partner of Ranveer, right? Automatically that will happen. Okay, I don't know Ranveer, I don't know. Okay, so this basically that is the point. So finally, I can say that here I can say this number will always be equal. Whatever you do, this number will always be equal. So this number will always be n. This number will always be equal. Now tell me, if this number is always equal, then what is the average number of partners for women? Tell me average number of partners. Average number of partners for women. Average number of partners for women, that is basically n divided by 3. And average number of partners for men, that will be n divided by 4. Who has more? On average, who has more partners? Okay, on average, you can notice that women has more partners. And why this is happening? What is the reason this is happening? Does it have anything to do with loyalty or something like, okay, does it have anything to do with that? No, because these two numbers will always be same. If you are partner of someone, then that person is partner of you. So in this world, okay, whenever some partnership is happening, then you can notice the number of men will increase, the number of women will increase by the same. The total number of partnership for men, that is also 5. The total number of partnership for women, that is also 5. So this number will always be same. But you can notice, because there are less women, because the population of women is less than population of men, so automatically the average number of partners for women will be more, and average number of partners for men, that will be less. Okay, so you can notice, if you know graph theory, if you understand graph theory, then you can save a lot of money. Like this ABC News, this Chicago University, like these people, they conducted research. Okay, but if you know graph theory, then you can do this. Yes or no? What you have to do? Can anyone tell me for India what you have to do if you want to find? Like you don't have to ask everyone. You don't have to go and ask, okay, how many partners you have? How many partners you have? You don't have to do that. So finally, okay, what you need to do? Because remember, this number will always be same. So whatever you do, only you have to find population. The only thing you have to do is you have to find population. Yes or no? So this is the final conclusion, that if I talk about India, so let me talk about India. Okay, then so you can notice that, let's assume that population of women, okay, that is less than the population of men. So now you can notice that if this number, let's assume this number is W and this number is M, let's assume, then finally tell me, like, what is the ratio? What is the ratio of number of average partners? What is the ratio of average partners of women to men? Average partners, average number of partners. Okay, so average number of partners, okay, for women to men. So that will be what? So remember, these are the average number of partners for women, and these are the average number of partners for men. So that will be basically M divided by W. and because m is greater than w, and because m is greater than w, so this value will be greater than 1. This value will be 1 point something. This value will be something. So can you notice that the ratio, if you notice the ratio of average number of partners for men to women, okay, for women to men, then that will be greater than 1. And the only thing, because these two will cancel out, see, this will always cancel out, because this number will always cancel out. So the final answer will be based on the population. The final answer is only based on the population. This has nothing to do with loyalty. This has nothing to do. So that is the reason. Okay, so this is your graph theory. Here you can notice, can you notice what we have done? What we have done, how we are using the graph theory? Because these are the dots and these are the lines. Yes or no? So this is where we are using the graph theory. So these men, all these men, I am not taking the exact men. For example, is there any man with the name A? Tell me, are they men? They are not men. These are abstraction of men. Can you notice? These are abstraction of men. This is an abstraction of men. So basically these dots and lines we have. These dots and lines we have. So this is graph theory. Is this clear to everyone? So this is not a man. For example, this D is not a man. This is an abstraction of man. This is representing a man. This Q is representing a woman. This P is representing a woman. Okay, so these are abstraction. So graph theory we are using to model the real life situation. Yes or no? In real life, in the real world, there are men, there are women. And what we are doing, we are representing those men and women using dots and lines. Okay, so these are the men, these are the women, and these lines, these are connecting the dots. So this is the very simple idea. So all the real life people, we are representing them using dots, using nodes. Okay, and we are connecting two nodes if they are in the relationship. So this is the idea. So you can use graph theory to answer this question. Yes or no? So very simple, because men are more than women. So finally, this number will always be same. And on average, always it will happen that women will have, on average, women will have more number of partners than men. Okay, so this will always happen. This will always happen. So can you notice that? Please, okay, so your assumption about all these things, your assumption, okay, that is wrong. Yes or no? Tell me, yes or no? That is wrong. Your assumption is wrong. Like how many on average who has more partner? So that assumption is wrong, because you can clearly see this has only this only has to do with what is the population. Is this clear to everyone? So basically in America, okay, these are the study. For example, University of Chicago, it studied, okay, almost, you can notice, almost 2,000 people it studied. Okay, and all the data were wrong. Why this data is wrong? Can anyone tell me? Like why this data is always going to be wrong? This data will always going to be wrong. The reason is because you are only taking a subset of people. You are only taking, yes, people lie. Yes, very good, Abhishek, very good. Because people lie. But mathematics does not lie. Can you notice this? Mathematics does not lie. Because if C is partner of he, then he is partner of C. Yes or no? So very simple. So that's the idea. So finally, what do you think? Mathematically, what do you think? Now, did you get your answer? So do your assumptions reflect reality? The answer is no. Proof by graph theory. You can use graph theory, and you can basically, in graph theory, what we have done. So these people we have represented using nodes. These people we have modeled. These people we have modeled, or I can say represented, okay, using nodes, or I can say dots. And this relationship between them, that we have modeled using what? That we have modeled or represented using what? Represented using, okay, so here you can notice represented using nodes, and the relationship between them, that is represented using lines, or I can say edges, connecting the dots, connecting the nodes. Okay, so this is the idea. So tell me, people are actual? Can I say people are actual? People are actual. Can I say people are actual? Like, are you actual? Yes, you are actual. you are actual entity. You are actual entity. These are the actual things, I can say. These are the actual entities. Okay, but tell me, nodes and dots, these are what? These lines and edges, these are what? These are abstraction. These are abstraction. Okay. Hi everyone. Now is it fine? I think the video paused. Now is it fine? Okay. Audio, video, is everything fine? Is there any lagging? Tell me. Okay. So let's see. So this is what I'm saying. People are actual entity. You can notice the people are actual entity. For example, you can notice Sandeep, Manisha, Jiren. So people are actual entity. Okay. And you can notice that nodes and dots, these are abstraction. And this relationship between people, this is actual thing. This is actual thing. But you can notice this lines and dots, these are abstraction. So graph is an abstraction. Yes or no? Graph is abstraction. Now let me take another example. And this is political example. This example I want to take. Okay, because many times people make their assumptions about the real world. They will make their assumption about some particular community. Yes or no? Like for a particular community, you will make some assumptions. Correct? Those assumptions, can you guarantee that your assumptions are correct? The party that you are supporting, can you guarantee that that party is good? Okay, so let's see. So how easy it is to manipulate public perception. I will give you one example, and that example, okay, you will get to know that that example will tell you that it is very easy. So for example, this is a Boston study. Let me tell you, this was a study for in the Boston. This was the study. They found that on average, minority students study with non-minority students more than the other way around. Yes or no? See, this is the study. Like they found this. They found that on average, minority students, they study with non-minority students more than the other way around. Like, for example, who is more friendly? Basically, what this is saying that minority students are more friendly. They are more friendly. Yes or no? This study is saying that minority people are more friendly. But tell me, can anyone tell me why this is happening? This study is saying that minority people are more friendly. Why this is happening? Why this is happening? This is a Boston study. This is a Boston study. Something, okay, it's like some. This is a Boston study that on average minority people are more friendly. Basically, this is saying that minority people are more friendly. So why they are more friendly? The reason is very simple, because they are minority. See, because they are minority. Just think about it. Just think about, these are the minority students. Okay, these are the minority students, and these are the non-minority students. Okay, so let's assume that there are only 3 minority students, and there are P, Q, R, S, T, U. There are these are the non-minority students. Now you can notice. Just tell me, if A studies with P, then P also studies with A. Yes or no? Agree? If A studies with P, then P will study with A. For example, if A study with Q, then Q study with. So you can notice. For example, P study with B, P study with C. Okay, something like this. Maybe Q study with B, maybe Q study with C. So from this, what actually is happening? Who is more friendly? Like, okay, from this, if you notice, who seems more friendly? Who seems more friendly from this? Like, what it looks like who seems more friendly? It looks like these people are more friendly. It looks like these people are more friendly. Okay, because you can notice, like it looks like these people are more friendly. But the idea is, this total number, if you find, this total number will be same as this total number. Agree? Yes or no? Yes or no? For example, this A studies with 2 people. A studies with 2 non-minority people. B studies with 3 non-minority people. C studies with 3 non-minority people. So this total number will be 8. So minority people, they study, okay, total, basically they have 10 study partners in the 8 study partners in the non-minority community. Now, this studies with 2 people, this studies with 2 people, this studies with 2 people, this studies with 2 people. So that is also total. Now tell me, on average, who studies, like who is more friendly? Tell me, on average, who is more friendly? On average. So on average, tell me, who is more friendly? Of course, minority people, because they are less, because this number will always be same. Whether minority is friendly or whether non-minority is friendly, it does not matter, yes or no. This number will always be same. This number will always be same. And because minority people are minority, okay, because minority people are less, so that is the reason on average, their average will be more. Yes or no? So this is the study of Boston. And if anyone, just think about it, if you forward this message in the group, in the WhatsApp group in India, in India, you can notice, if you forward this message on the group that minority people are more friendly, okay, like something like that. So that does not give you the actual picture. Okay, because remember, whoever, like, it does not matter whether minority people are more friendly or non-minority people are more friendly, that does not matter, because on average this data will always be there. Like on average minority people will always be more friendly than non-minority people. It does not have anything to do with the reality, yes or no. It does not have anything to do with the reality, yes or no. So that is the idea. The data, you can use the data to manipulate people. So it is very easy to manipulate public perception, yes or no. Very easy to manipulate public perception. So anyway, so here also we are using the graph theory. So to solve this question, this is the problem. Okay, this is the problem, like who is more friendly. So this is the problem. And to solve this problem, you are using the graph theory. Basically what you are doing, you are creating nodes. So these nodes you are creating, these are the nodes. Okay, and these are the lines, which are the relationship. Okay, so these are the lines which are connecting the dots, which are connecting the nodes. So using the graph theory, you can very easily see that you can easily solve this problem. You can easily solve this mystery. Yes or no? Agree? So did you understand that? Okay. So from now onwards, do your assumptions reflect reality? The answer is no. The answer is no. Okay. I want to tell you one more thing here. Okay, just think about it. If some particular news is reaching you every day, then what you will think? You will start thinking, okay, on that particular news, you will start thinking. For example, let me just tell you one thing. Okay, for example, murder. Okay, for example, murder. In just assume that in let's assume in 2018, let's assume in 2018, the number of murders that are happening in India. For example, let us assume, oh, every day, let's assume 1,000 murders are happening per day. Let's assume, but this news is not going to you. Let's assume this news is not going on TV. Okay, so every day, let's assume this is the assumption. So assume that this is happening. Okay, assume, and this news is not reaching on TV. Now let's assume that in 2022, let us assume that only one murder is happening per day. Only one murder is happening per day. Just assume. But this news every day, this one murder, okay, this brutal murder, let's assume this brutal murder, there is a brutal murder, okay, something like that. Okay, so now tell me, this news is reaching every day on your TV. Then tell me, which situation is actually better, 2018 or 2020, 2022? Which situation is actually better? Tell me, which situation? Yes, this situation is actually better. This is actually better. But what you will think, this is actually better, but what you will think, see, this news is not reaching you. This news is not reaching you. Okay, but this one murder every day, one murder news is reaching you. Okay, is reaching you. So what you will think, your perception will be, but your perception, what perception will become? So the perception will be that, okay, that 2018 was good. This was the perception. This will become the perception. So it is very easy to manipulate the perception. Very easy to manipulate your perception. So anyway, just let me tell you one thing, that what you think you know, maybe that is wrong. The party that you support, maybe that party is not good for India. Okay, maybe the community that you hate, maybe that community you should not hate. Okay, so basically whatever are your assumptions for the world, maybe they are not correct. Okay, so I'm not talking about any specific party, I'm not talking about any specific community, I'm talking about mathematics. I'm only talking about mathematics. Okay, so this is what I'm saying. So anyway, it is very easy to yeah. So does your assumption reflect reality? The answer is no, and the proof is by graph theory. Very simple. Is this clear? So you can notice graph theory is very interesting field. Yes or no? Let's see one more example. The third situation. And this is where graph theory started. Let me tell you. Like if anyone asks you from where graph theory started, then graph theory was started by Euler. Okay. So this Euler, he started the graph theory. And let me tell you why this graph theory started. So actually there was a town. This type of town was there. This is a real town actually. Okay. So in 1736, this Euler started graph theory. So what was the situation? The situation was this: in Russia, there is a town. Okay. This town was there, Königsberg. This town was there. I don't know. Okay. Maybe is there. I don't know. Okay. So this town is there in Russia. And in this town, this type of situation is there, that in this town you have bridges. Total how many bridges you have? Total 7 bridges you have. So basically there is a land, like this is the land, this is the land, and you can notice. Okay, so this is a land, and this is a land. So you can notice there are 7 bridges, and this is the river. Okay, so this is the idea. So this was the idea. Now this was the question that mathematicians were thinking. The mathematicians were thinking, can, okay, for many years, let me tell you, for many years, mathematicians were thinking about this problem, that we want to visit, we want to cross all the bridges exactly once. So what you have to do? Your task. What is your task? Your task is to cross every bridge exactly once. For example, okay, if you start here, then you have to cross this bridge exactly once. 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 Then exactly once. Then exactly once. Now, tell me, can you cross this bridge number 5? Can you cross this bridge number 5? No, you cannot cross this bridge number 5. You cannot cross this bridge number 5. So what you will do? You will have some other approach, some other approach. Okay, you start from here. What you will do? You will start from here. You will start from here. You will cross this bridge. 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 Okay, you will cross this bridge. You will cross this bridge. Now, can you cross the bridge number 5? Again, you cannot cross the bridge number 5. So what I am saying? I am saying that this was the problem. This was an open problem for many years, almost 200 years. Mathematicians were thinking about this problem. Like, is there any way we can visit, we can cross all the bridges exactly once? Okay, you cannot, for example, you cannot do this. Like, okay, you cannot do this. No, you cannot do this. You have to cross every bridge exactly once, not more than one, not less than one. So this was the problem, and mathematicians could not answer it. So tell me, what is your obvious solution? Like, which solution you will give? The most obvious solution, if you were at that time, then you will check all the possibilities. This is what you will do. You will check all the possibilities, but mathematicians don't do that. Yes or no? So mathematics, of course, there are only 7 bridges. So what you can do, you can check all the possibilities, and you can tell that there is no way. There is no way to cross all the bridges exactly once. There is no way. But mathematicians don't think like that. Mathematicians, for example, if there are 1,000 bridges, then how will you do? Yes or no? If there are 1,000 bridges, how will you do? So mathematicians want some generalization. Mathematicians want to know why it is happening, why it is not happening. Okay, so this was open problem, and for 200 years no one could answer it. No one. Then this person came, who Euler. And what he did, see, this is an actual city, and what he did, he created a graph from this. He created a graph from this, and this was the first graph in graph theory. This was the first graph. So what he did, he created a graph like this. So he called, okay, so let me call it, what I will do, let me call it land number A. Okay, let me call it land number B, land number C, and land number D. Okay, so you have total four piece of land you have. Now you can notice here, total 7 bridges you have. So what graph? So what Euler did? Euler created graph. Euler created a graph like this. So tell me, first of all, you tell me, are these the piece of land? For example, let's assume this is some city. Let's assume this is some city. So tell me, this A, B, C, D, what are these? What are these? These A, B, C, D. This D, what is this? This is abstraction. Yes or no? Yes or no? This is abstraction of this. This is abstraction of this area. Yes or no? Yes or no? This is abstraction of this area. Correct? So this is the abstraction of this area. Now you can notice that you can notice this A is connecting to D. A is connecting to D with breeze 1 and breeze 2. So A is connecting to D with breeze 1 and breeze 2. Breeze 1, breeze 2. Okay. Next you can notice that this D is connecting with B with breeze 3. D is connecting with B with breeze 3. Next, D is connecting with C with breeze 5, 6. With breeze 5, 6. These are the breezes. And then finally, you can notice A is connecting with B with breeze number 4. With breeze number 4. And finally, this B is connecting with C with breeze number 7. So what Euler did, this is what Euler did. This is what Euler did. Euler did this. So this Euler created an abstract picture, abstract structure. This is an abstract structure on his paper. So this is the abstract structure he created. In this abstract structure, this is the abstraction, and this is also abstraction. This is abstraction for what? So this is abstraction of land, and this is abstraction for what? This is abstraction for bridges. This is abstraction of bridge, right? Yes or no? So very simple. So this abstract structure, this Euler created. So this structure is called graph. So graph is an abstract structure. You can notice in this structure, you can notice you have some nodes. So there is a node and there is a line. This is your edge. And now for this graph, Euler proved. We will see the proof after some time. We will study this Euler problem. Okay, right now I will not tell you the proof, but let me tell you that after some time we will study the proof. We will study the proof that what Euler did. So Euler created this structure, abstract structure Euler created, and for this structure Euler proved that we do not have any way to visit every bridge exactly once. There is no way. You can start from anywhere you want, but there is no way you can cross all the bridges exactly once. You can cross every bridge exactly once. There is no way. Okay, there is no way. So to do this, to prove this, what Euler did, Euler created a graph, and this is the first graph. So basically, Euler started the graph theory. So if anyone asks you who is the I can say founder of graph theory, then Euler is the graph theory founder. Okay, and this was this 7 bridges of Königsberg. This is the first problem of graph theory. Okay, and this is very interesting. Now let me tell you, actually this is not very hard. We will study this after some time. We will study, but let me tell you that, okay, how Euler did it. This is generalization. So let me tell you the generalization. Actually this is not very hard to understand. You can very easily understand this. Just tell me this point. Idea is this. Idea of Euler. What was the idea of Euler? Idea was like this. See, tell me, if let's assume that you want to visit every let's assume that this is your city. Let's assume this is a node, and tell me, if you want to visit every edge exactly once, this is what your target. Your target is to visit every edge exactly once. This is your edge. Let's assume this is your edge. You want to visit it exactly once. So this is done. Now let's assume there is some other edge. That if there is some other edge, then you have to go out. Definitely. For example, you started from here. Okay, you started from here. Now you have to go out. Yes or no? Okay, because you cannot take this way. See, you took this way. Now you again cannot take this way, because we have to visit every bridge, every edge exactly once. You cannot visit any edge more than once. So if you are coming by this edge, then you cannot use this again. Done? Yes or no? Agree or not? You cannot use this again. So this is the idea. So for example, here also you can notice, in this example also you can notice that if you take this edge, let's assume you start from here. You start from here. If you take this edge, then you cannot take this edge again. You have to take some other edge. Yes or no? You have to take some other edge. You have to take some other edge. Now you cannot take this again. So you have to take some other edge. So the idea is this, that if you take some other edge, and let us assume you again come back. Let us assume you again come back. Then tell me, there should be a way out. This is your way in. If this is your way in, then there should be a way out. Yes or no? there should be a way out. Agree or not? So can you tell me what should happen here? Okay, I can say that, okay, this should happen that for every vertex, this should be even. This should be even. If there is a way in, then there should be a way out. There should be, if there is a way in, then there should be way out. Okay. So anyway, this we will come back. We will come back to this point after some time. So don't worry about it. I will tell you the proof. I will tell you the proof when we study this Euler problem we will study. There is something called Euler circuit. This topic we will study, and at that time I will come back to this problem again. And at that time I will tell you the proof. Okay. So so this is the generalization of Euler. So what Euler did, this was the problem. This was an open problem for 200 years. Mathematicians could not solve it. So Euler created a graph. This is the abstract version of the Königsberg city. And for this graph, Euler basically created a theorem. Euler created a statement. Okay. So this is the idea. So anyway, graph theory is very important. And this is the motivation for graph theory. So like graph theory, this is very important. And you can notice another application of graph theory. Can anyone tell me what is your, like every day you are using graph theory? In which application? In which application you are using graph theory? What is the most obvious application for graph theory? Dots and lines. Dots and lines. In which application you are using dots and lines? Google Maps. Yes or no? Google Maps. This is the most simple application where you can notice dots and lines. Like your cities are the dots, and okay, these are the lines, these are the roads, something like this. Yes or no? So you are using this graph in Google Maps every day, dots and lines. Okay, so this basically in computer science, okay, in mathematics, so in every field, whatever field of computer science you take, and there are many fields which are not of computer science, but this graph theory is very important in every field. Okay, so this is the idea. Yes, internet is also a very huge graph. Yes, if you notice the internet, that internet is also a very huge graph. For example, this is your laptop, this is some other laptop, this is a router, this is a laptop, this is a laptop. So internet is also a very huge graph. Internet is basically a very huge graph. Okay, so this is the idea. Is this clear? So very simple. So if anyone asks you what is graph theory, this is the definition. In interview, if they ask you graph theory, what is the definition of graph theory, this will be your answer. So graph theory is a field of mathematics. This graph theory, okay, this graph theory is a field of mathematics in which we use structure of dots and lines. This structure we use to model real world problems. We represent the real world problems using this structure of dots and lines, and we solve them. So your real world problem you represent using dots and lines, and you solve it. That is your graph theory. So this is the definition of graph theory. Why we study graph theory? Because it is in the syllabus, and also many real life problems you can represent, you can model using graph. So basically graphs are tools to solve problems. Okay, many examples you can take like Google Map, Facebook, many other examples you can take. Okay, so all these things. So this is the definition of graph theory. In graph theory, remember one thing you remember, this graph theory is an abstract structure. If you notice, this graph is an abstract structure, correct or not? This is an abstract structure. This graph is a model of real world. This is a model of real world. This graph is a real model of real world. So I can say this is model. Model means representation. This word model means representation. So I can say this graph is a representation of real world. So, okay, in this graph we have two things. In this graph we have something called nodes. So we have two things, nodes and edges. These are the two things, and these two things are also abstractions. These are also abstractions of real world entities. These are also abstractions of real world entities. These, okay, real world scenarios, real world things. Okay, correct? So very simple. This is the idea. Now let's start. So now we will start our chapter. So this was the motivation. Like, are you excited about the graph theory now? Like, did you understand why graph theory is very important for computer science? And why graph theory is very important for your GATE exam. In GATE exam from graph theory, you will definitely get almost 5 or 6 marks you will get from graph theory. And graph theory is very easy. Okay, we will study graph theory from GATE exam point of view and also from any exam point of view. By chance, if you get if you do not crack GATE exam, then you can definitely crack some other exam like ISRO, BAR, DRDO, okay, NILIT, some other exam you can definitely crack, okay, and you can definitely crack interview. And this graph theory is very important chapter for interview. In every interview, okay, like these are the chapters for interview. For example, linear algebra, probability, okay, graph theory, algorithm, data structure. These are the concepts they will ask you in interview, and this graph theory is one of them. So now we will start. Okay, so what is a graph theory? Graph theory is a basically graph theory is a structure of dots and lines. So dots are called, these dots, let me tell you, these dots are called, another name is nodes. You can call them dots, or you can call them nodes, or you can call them points, or you can call them vertices. This is the word we will use. So these two words we will use, vertices and nodes. Vertex, basically vertex. Okay, so you can call them vertex. And similarly, these lines which are connecting the nodes, these lines we will call them edges. Some people call them branches. Some people call them branch. So anyway, this word we will use. Okay, so vertex and edges, these two words we will use. So what is a graph? So graph is basically, any graph has two things. There will be set of vertices and there will be set of edges. This is a set. This is a set of nodes, or I can say this is a set of vertices. And what is this? This is a set of edges. This is a set of edges. Okay. So in every graph you have two things, dots and lines. Very simple. This is the simple definition of dots and lines. Now, let me tell you one more thing before we start our chapter. So in graph theory, many concepts, many definitions, they are author dependent. Okay, there are many definitions which are author dependent. For example, if you study different books, if you study 10 different books, then you will find many different definitions for some term. Okay, for example, this term walk, path, okay, trail. This is called trail. This is your trail, no train. Okay, like Euler graph, empty graph, null graph, empty graph is bipartite graph. All these concepts, they are author dependent. Okay, so what I will suggest, see, many times people waste a lot of time. Okay, many times students will come to me and they will ask, sir, this definition you told us, but in this book they are saying other definition. Okay, so remember, in graph theory many concepts are author dependent. So all the definitions that we are taking, follow them, because all the definitions that I am taking, these are the definitions that are used in most referred standard resources in IIT ISc course. So in our course of IISc and also in NPTEL courses, the definitions that are followed by most of the authors, those definitions I have taken. So only follow, okay, our definitions. You don't have to worry about the GATE exam, because the professors of IIT ISc who will create your questions in the GATE exam, they know everything. So there will be no ambiguity. If you solve all the GATE exam questions, there will never be any ambiguity. So do not worry about these author dependent concepts. Use the definitions, okay, which we are going to use in our lectures. Okay, so please don't come to me and say that, sir, in this book this definition is given. Okay, don't do that, because every definitions that we will take, I will give you a screenshot of standard resource. Okay, so if by chance, if there is any ambiguity in any GATE question, then you can challenge, because all the definitions that we are taking from standard resources. We are taking from NPTEL courses, or I can, okay, and I am taking from my ISc course. Actually, I have done my specialization in graph theory. So if you go to ISc, then in ISc there are 3 pools, I told you. If you go for MTech, then there are 3 pools. There is a pool A, pool B. This pool A is theory pool, and there is a pool B, and there is a pool C. This is a theory pool. In this you have this type of subject like algorithm, data structure, okay, graph theory, this type of courses you have. This is a theory pool. In pool B you have system pool. In this you have this type of courses like operating system, computer organization, compiler design. In pool C you have your favorite courses, machine learning, okay, game theory, so okay, data science. So basically this type of courses you have. And in this theory pool you have these type of courses like algorithm, graph theory, this type of courses. In system you have like operating system, compiler design and all. Okay, so basically whatever pool you select, that is your choice, but I have done my specialization in this theory pool from graph theory. So this graph theory was my specialization from ISC in for my MTech. Okay, anyway, so I just want to tell you that all the definitions that I am taking from ISC course and NPTEL courses, so you don't have to worry about the definitions. Just follow our definition and you will never have to worry about any question. Is this clear to everyone? Tell me, is this clear? Okay, now, so let's start now. So what is a graph? I told you, graph is a set of vertices and set of nodes. For example, this is a graph. In this graph, how many vertices you have? Tell me how many vertices you have. So in this graph, you have total 5 vertices. So this is the set of vertices. So remember, this is a graph. In this graph, you have set of vertices, set of edges. So there are total 5 vertices. So the set of vertices is 1, 2, 3, 4, 5. This is the set of vertices. And this is the set of edges. How many edges you have? Total 4 edges you have. For example, this edge is 1, 2. Okay, for example, what I'm saying, like this is your graph, 1, 2, 3. This is your graph. Let's call it graph G. So in this graph, you have two things: set of vertices, set of edges. What is the set of vertices? 1, 2, 3. These are the set of vertices. Okay. And what is the set of edges? This is the set of edges. You can notice this edge is connecting 1, 2. So this is your 1, 2. Okay. Yes or no? Because this is connecting 1, 2. So this is the edge 1, 2. And can you notice this is a set? Should I write like this or should I write like this? Which is correct? First one or second one? Which is correct? First or second? Which is correct? First is correct because there is no direction here. This is a line which is connecting 1, 2. This is a line which is connecting 1, 2, 1, 2. Okay, so that is the reason I can say this is correct. Okay, so this is a edge. This edge is a set. This edge is a set, and this another edge is connecting 1, 2, 3. This edge is connecting 2, 3. So total how many edges you have? So tell me total how many vertices? 3 vertices. Total how many edges? 2 edges. You have total 3 vertices, 2 edges. Okay, very simple. So this is the definition of a graph. Now let's move on. Now we will see type of edges. What are the type of edges in a graph? There are many different type of edges in a graph. Let me tell you one more thing here. In this, if you notice, okay, this edge, let's call it this edge E1, this edge E2, and let's call it E1. Then you can notice this is your edge E2 and this is your edge E1. So these for E2, if you notice this E2 is like this. Okay, there is 2 here, there is 3 here. This E2 is like this. So this is the end point of E2. We call it end point of E2. This is the end point of E2. And this is also end point of E2. So tell me, who are the end point of E1? Who are the end points of E1? These are the end points of E1. So end points of E1 are 1, 2. So if I ask you what are the end points of E1, end points of edge E1, then that will be 1, 2. These are the end points of E1. And these are the end points of E2. So this is the end point of E2. This is end point of E2. So for this edge E2, there are 2 end points. Okay, 2, 3. So very simple. Now, one more thing, let me tell you that, tell me, this graph, is this same as this graph? Are they same? Are they same? Is this graph same as this? Are they same? Are these graphs same? Are all these graphs same? Yes, all these graphs are same, because remember, graph is an abstract structure. Do you remember? Graph is an abstract structure. Yes or no? So it does not matter how you draw it. The drawing does not matter. The drawing does not matter. The drawing really does not matter. Okay. So don't say that these are different graphs. The drawing really does not matter, because graph is an abstract structure. Like for example, this is a real world situation. In this real world situation, 1 is friend of 2, 2 is friend of 3. Okay, so this real world situation is same as this real world situation. You can notice 2 is friend of 3, 2 is friend of 1. Here also 2 is friend of 1, 2 is friend of 3. Here also 2 is friend of 1, 2 is friend of 3. So these are definitely same. But if I do this, now are they same? If I do this, are they same now? Now these are not same. Now these are not same. Okay, so anyway, what I'm saying that the drawing really does not matter. Drawing never matters in graph. Okay, so anyway, so this graph you can draw like this, there is no problem. Okay, now let's move on. Now we will see type of edges. What are the different type of edges? First we will see what is undirected edges and what is directed edges. This is the first classification. What is the directed edge and what is undirected edge? So you have directed edges and there is something called undirected edges and directed edges. So what is a undirected edge? Undirected edge is like this. If you have two nodes, undirected means there is no direction. This type of edge is undirected edge. And what is a directed edge? There is a direction. There is a direction. Okay, so remember, for the directed edge we have a direction, and for undirected edge there is no direction. So this edge, if okay, let's call this edge. So this edge I can write as a comma b as a set. This edge is basically a set. If you notice, this is set of 2 points, and if you notice this edge, then this is from a to b. Yes or no? This is from a to b. This is not from b to a. This is from a to b. So we will write it as a ordered pair. This we will write as a ordered pair. This edge we will write as ordered pair, means this is from a to b. This is not from b to a. Can you go from b to a here? Can you go from b to a? No, you cannot go. But tell me, can you go from b to a here? Yes, you can go. So undirected edge has no direction, and in the directed edge we have direction. So this edge, this type of edge which has no direction, this type of edge is called undirected edge. And this type of edge which has direction, this type of edge is called directed edge. Okay, very simple. In this directed edge, this is called the initial. So this is called the source, because this is from a to b. So this is called source and this is called terminal. Okay, this is called source and this is called terminal, because you are going from a to b. This edge is from a to b. So this a is called source. Okay, and this b is called terminal or destination. Right, terminal, or I can say destination. So this is the destination node. You can call it destination. And okay, here this a comma b, these are endpoints of e. In this undirected edge, we have no source or destination, right? For the undirected edge, we don't have source or destination. We don't have. So what we have endpoints. So we say that endpoints of e. What are the endpoints of e? So if anyone asks you what are the endpoints of e, then you can say a comma b. These are the endpoints of e. So this is the undirected edge and directed edge. Did you understand this classification? Another classification, the second classification is self loop, or simply you can call it loop. This is the self loop. What is this? This is an edge which is connecting same vertex. Basically, edge whose endpoints are same. Edge whose endpoints are same. Whose both endpoints are same. Both endpoints same. Okay, so what this means, that this type of edge, for example, this vertex you have, and this type of edge, this is called self loop. This is called self loop. So you can notice what is the difference between these two. What is the difference between these two? The difference between these two. This is a self loop in undirected. This is an undirected edge which is self loop. This edge is a self loop undirected. This is a self loop but undirected. There is no direction here. And this is a self loop but directed. So this is a self loop which is directed self loop. Okay, so anyway, so basically this type of edge will be used in directed graph. In the directed graph we write this type of edge, and in undirected graph we write this type of self loop. So this self loop, the definition is very simple. Self loop means, or I can say loop, that means edge whose both endpoints are same. Whose both endpoints are same. This type of edge is called self loop. Okay, Yuvraj, what I'm saying that, see what I'm saying, in directed graph you will use this type of self loop. In undirected graph you will use this type of self loop. That's the only difference. No other difference. There is no other difference. Is this clear? In the directed graph you will use this type of self loop. In undirected graph you will use this type of self loop. Okay, so these are basically two different structures. Directed, undirected. These are two different structures. Okay, so don't mix them. These are two different structures. I will take example, and with example I will explain where these structures are useful. Okay, so let's see another classification. The third classification is multi-edges. What is this multi-edges? Multi-edges, or you can call it parallel edges, or you can call it parallel edges. So let me tell you the definition of multi-edges. When can you say multi-edges or parallel edges? These are basically the same edges. Basically, exactly same edges. Exactly. Remember, exactly same edges. Exactly same edges. For example, if you notice, in directed graph, in undirected graph, this type of edges. In undirected, if you have undirected graph, then for example, let's assume A is there, B is there. Okay, there is A, there is B. Now notice this edge and this edge. This edge E1 and this edge E2, are they exactly same? Can you say they are exactly same? Multi edges or parallel edges? Parallel edges, that means basically, are they exactly same? Yes, E1 and E2, they are exactly same and they are A comma B. E1 and E2, they are exactly same, correct? So I can say these are parallel edges. These E1, E2, these are parallel edges. These are parallel edges. E1, E2 are parallel edges. Okay, is this clear? E1, E2, these are parallel edges. So what we will say that these are parallel edges. E1, E2, these are called parallel edges. Okay, in directed graph, if you have a directed graph, let's assume if you have a directed, then in directed graph, tell me, this edge, is this parallel to this? Are they exactly same? Are they multi edges? Are they multi edges? They are not multi edges because they are not same. So can I say these two, are they exactly same? Are these two exactly same, E1 and E2? Yes, E1 and E2, they are exactly same. They are from A to B. So this E1 and E2, these are called multi edges. Here this E1 and this E2, these are your multi edges. Multi edges. Okay, is this clear? Remember, not that these are not parallel edges. These are not this A, B, okay, this and this. These are not multi edges. Here E1 and E2 are different. E1 is not same as E2. E1 is from A to B. E2 is from B to A. These are completely different. So E1 comma E2 are not multi edges. Are not multi edges. Okay, they are not multi edges. They are not parallel edges. Okay, because they are different. They are completely different. For example, this is your from A to B you are going, and this is from B to A. If you want to go from A to B, you have to take E1. If you want to go from B to A, then you have to take E2. So they are different. Yes or no? If I remove E1, then you cannot go from A to B. But you can notice here E1 and E2, they are same. Both are A comma B, from A to B. Here also A comma B. Here also E1 E2 are same because they are between A comma B. So is this clear? Multi-edges definition. Basically, the exactly same edges. There should be exactly same edges. This is the definition of multi-edges. So here E1 and E2, they are not multi-edges. Okay. Now let's move on. So this is the age classification. So we have seen the complete age classification. Okay, so anyone has any doubt in this age classification? Is there any doubt in this age classification? Undirected, directed. Undirected edges, there is no direction. Directed edges, there is a direction. Okay, then we have seen self loop. Self loop means connecting to itself. Okay, like liking your own picture. When you like your own picture, that is your self loop. Yes or no? So that is the idea. Multi-edges means there are exactly same edges but multiple. Okay, now let's move on and let's see the, okay, so we have seen what is the definition of graph. We have seen what is the definition of endpoint. We have seen what is the definition of loop edge. We have seen what is the definition of parallel edges or multi-edges, that we have seen. Now let's see type of graph. Now based on, so this type of graph based on type of edges. So this is the type of graph based on type of edges, based on edge types. So what type of edges you have, depending on that, you can classify the graphs. For example, you can have something called undirected graph. Can anyone tell me what do you think? What is the definition of undirected graph? Undirected graph means all the edges are undirected. All the edges are undirected. Okay. So that is the definition. Yes, Avni, I will cover. Don't worry. Don't worry. Nothing will be left. I will cover incident age. I will cover. Okay. So let's see. So undirected graph. What that means? Undirected means every age is undirected. Means every age is undirected. If there is any age, that should be undirected. If there is any age, that should be undirected. So for example, tell me, is this undirected graph? Is this graph undirected? Yes. Is this graph undirected? Is this graph undirected? Is this graph undirected? Yes, because if there is age, it should be undirected. If there is any age, it should be undirected. Is this undirected? Is this undirected? No. Is this undirected? Is this undirected? Yes. Okay. So undirected graph means every age must be undirected. Okay. So for example, is this undirected? A, B. Is this undirected? For example, this graph I am talking about this graph. So between A comma B, there are three edges. Okay, between A comma C, there is no edge. So this is also undirected. Undirected graph means every edge must be undirected. And the same definition you can do for directed graph. So what will be directed graph? Every edge must be directed. Every edge must be directed. This is not a directed graph. Is this a directed graph? This one. Is this a directed graph? Yes, this is a directed graph. Because every edge must be directed. If there is any edge, it should be directed. Next, is this directed graph? Is this directed graph? So yes, this is directed graph. Next, this is actually, if you do this, now this is directed graph. Now this will be directed graph. And this is not a directed graph. Okay, so directed graph means every edge must be directed. Very simple. So this is the classification of graphs. Now the few more classifications. These are the important classifications. Directed graph, undirected graph. This is important, but there are some more. Okay, in the GATE exam, these are not important, but there are some more. The third is called something called, there is something called multigraph. Multigraph. Okay, what is this multigraph? If I don't mention anything, then it means I am talking about an undirected graph. So what is a multigraph? This multigraph had two things. First of all, it should be undirected. First of all, it should be undirected graph. It must be undirected graph, and also no self loops. No self loops. Okay, so this type of graph is called multigraph. Multigraph means there should be no self loop. We should not have any self loop. In the multigraph, multi edges allowed. Multi edges are allowed. Multi edges allowed. So you can have multi edges, okay, but you cannot have self loops. Is this clear? Yes, Manisha, single node. This is directed graph also, undirected graph also, because there is no edge. Because there is no edge, you can notice that this is the classification of graph based on edge types. What type of edges you have, which type of edges you have, depending on that you are classifying the graph. So if there is no edge, then we don't have to worry. Yes or no? If there is no edge, you don't have to worry. So anyway, multi-graph means multi edges are allowed. This should be undirected and this should be no self loops. But this is important, no self loops. Okay, so basically I can say, for example, this graph, is this multi-graph? Tell me, is this graph multi-graph on your screen? Yes, this is a multi-graph. No self loops. This is the definition. Arpan, this is the definition. This is the definition of multi-graph. This type of graph you called multi-graph. That's it. This is just a definition. This type of graph you called them multi-graph. Is this a multi-graph? Tell me, is this a multi-graph? Yes, this is also multi-graph because multi-edges are allowed. It does not mean that you have to have them. This is allowed. It is not mandatory. Okay, so tell me, is this multi-graph? Is this multi-graph? This is not multi-graph. Okay, so multi-graph is undirected graph with no self loops. Very simple. Undirected graph with no self loops. Next, the fourth is there something called pseudograph. What is the definition of pseudograph? Pseudograph is basically any undirected graph. Okay, pseudograph is basically any undirected graph. Every undirected graph is your pseudograph. Okay, means in the pseudograph, what we allow? What we allow? Self loops allowed. Self loops are allowed in this pseudograph. Self loops allowed, and I can say multi edges allowed. Parallel edges are also allowed. So this is the definition of pseudo graph, means basically any undirected graph. Whatever undirected graph you have, this should be undirected. If I do not mention anything, it means undirected. Okay, if I do not mention anything, it simply means undirected. So remember, this is so. For example, this graph, if you notice, this graph is your pseudo graph. Okay, this graph is pseudo graph. So for example, this graph is this pseudo graph. Here we have, remember, here we have multi edges also, self loop also. So here 3 self loop, and these are multi edges also. These are multi edges also. Okay, yes or no? So very simple. Now this is the definition. Now there is something called, now the fifth is directed multigraph. Directed multigraph. Now this is the name, directed multigraph. In this directed multigraph, basically everything is allowed. So there is something called directed multigraph. In this directed multigraph, if you notice directed multigraph, this should be directed and everything is allowed. So it simply means that any directed graph. In directed multigraph, it simply means that any directed graph. Okay, remember here self loops are also allowed, any directed graph. But these things are not important. In the GATE exam, they will give you the definition. So again, this definition is author dependent. This definition is author dependent. So they will give you the definition. You don't have to worry. Okay, so just follow this definition that I am giving you, because the definition that we are using, this is from standard resources. For example, the definition that we are taking, these are from Kenneth Rosen. Okay, so that is the idea. Okay, anyway, so directed multigraph, that simply means any directed graph. Self loops allowed. So self loops allowed and multi edges allowed. Okay, so for example, this type of graph A, B, this type of graph is a directed multigraph. Now, important thing, what is important? This is important. This is very important, extremely important. And this is called a simple graph. This is called a simple graph. If I do not mention anything, then what it means? If I do not mention anything, what it means? Simple graph. It simply means undirected. Yes or no? So simple graph is the name itself is telling you this is a very simple graph. So first of all, this is undirected. First of all, this is undirected. Second, there are no self loops, no multi edges. You should not have any self loops. There are no self loops and there are no multi edges. We don't have any multi edges and self loops. So very simple. This is called simple graph. For example, is this a simple graph? A, B, is this a simple graph? This is not a simple graph. For example, is this a simple graph? Is this a simple graph? Tell me, is this a simple graph? Yes, this is a simple graph because we don't have self loop, we don't have multi edges. So this is a simple graph. Is this a simple graph? Is this a simple graph? No, this is not a simple graph. Simple graph is undirected, without self loop, without multi edges. A, B, C, D. Is this a simple graph? Is this graph simple? Yes, this is also simple because there are no self loops, no multi edges. There are no self loops, there are no multi edges, and it is undirected. So I can say this is also simple graph. This is the important definition. Okay. Now, similarly, you can have simple directed graph. What is a simple directed graph? If I ask you, what is a simple directed graph? Simple directed graph. That simply means, again, this is a directed graph with no self loops and multi edges. This is a directed graph. Okay, no self loops. There should be no self loops and no multi edges. There should be no multi edges. So this type of graph is called directed simple graph. So tell me, is this a directed simple graph? Is this a directed simple graph? Yes. Okay. Now you tell me this. Is this a directed simple graph? Is this graph directed simple? Is this graph directed simple? Is this simple directed? Yes, because these are not multi edges. I told you these are not multi edges. This is fine. This is fine, but this is not fine. This is not fine. Okay, and also this is not fine. So these are the definition, and this is the classification of graph. So you can notice what is important definition. The definition which is important is a simple graph. This definition is very important, extremely important. And another definition that is important is simple directed graph. These two definitions are important. Other definitions are not important. Okay, but remember, okay, so you can take, for example, these you can also remember these four definitions. You can remember what I'm saying. These four definitions. Okay, only these four definitions you have to remember. You don't have to remember these last two. You don't have to remember. These first four definitions are important. Is this clear? Simple graph means undirected. Self loops no, and multi edges no, and self loops no. Is it clear to everyone? All these definitions, are they clear? Let's take this question. Like, so okay, notice this graph A, B. Notice this graph. Actually, what is happening here? Here you can notice that graph is a set of, this is a multi-graph, right? I can say this is a multi-graph. This is a multi-graph. And you know that graph is set of vertices and set of edges. So set of vertices is A comma B, that is fine. But tell me, what is set of edges? What is set of edges? Tell me. What is set of edges? What is set of edges? That is A comma B, A comma B. Is this a set? Is this a set? Tell me, is this a set? In this you have two same elements. In this you have two same elements. Two same elements you have. Is this a set? So this is a multi-set. Remember, this is not a set. This is a multi-set. So in a multi-graph, we have multi-set. If anyone asks you the definition of multi-graph, so what will be the definition of multi-graph? The definition of multi-graph is basically, this is an undirected graph. So the definition is undirected. It should be an undirected graph. And also you have set of vertices and multi-set of edges. Remember, this is a set of vertices. There is no problem here. There is no problem here, set of vertices. But there is a problem here. This should be a what? This should be a set or multi-set. This should be a set or multi-set. This should be a multi-set. This should be a multi-set of edges. Okay, for example, here two edges are same. So this is not a set. This is a multi-set. This is not a set. So this is a multi-set. Is this clear? Okay. And how will you represent this graph? For example, A, B, this graph. How will you represent this graph? So this is a directed graph. This graph, what is this? This is a set of vertices and a set of edges. So first of all, this is set of vertices, means A comma B. These are the vertices. This is a set of vertices. And this is a set of edges, but every edge is ordered pair. This is set of edges, but this is every edge is an ordered pair. Like from A to B we have edge, from B to B we have edge. So here I can say this is set of edges. This is a set of edges, but every edge is a ordered pair. Ordered pair. So this is the simple definition. Okay, is this clear? So this is a simple directed graph. This is a directed simple graph. This is the definition of directed simple graph. In a directed simple graph, you have set of vertices and you have a set of edges. You have set of edges where every edge is ordered pair. Okay, very simple. So all these definitions, they are clear. Now we can move on. So here you can notice all these definitions I have covered. Oh, sorry. This is directed simple graph. So there should be no self loop. There should be no self loop because this is directed simple graph. This is a directed simple graph. So there should be no self loop. We should not have any self loop. Okay, so this is correct because this is a directed simple graph. The definition of directed simple graph does not allow self loops. Okay. Now, one more thing I want to tell you, that for convenience, only for convenience, we will use, okay, see, only for convenience. This is only for simplicity, for convenience, so that we don't spend more time in writing. Okay, this is only for convenience, that if you have an undirected graph, and let us assume you have this edge, A, B, this edge you have, then actually this is correct. See, I should write like this. But for convenience, what I will write? For convenience, I will write as AB. For convenience, I will write as AB. So remember, if I have undirected graph, and if I tell you that in undirected graph, if I tell you that you have age AB, then is any ambiguity? Do you have any ambiguity? I tell you that in undirected graph, you have this age. Is there any ambiguity? There is no ambiguity, right? There is no ambiguity, right? Yes or no? So for convenience, this we will write like this. This is just for convenience, nothing else. This is just for convenience. Okay. So this is the idea. But if I tell you that there is a directed graph, this is what I tell you, that there is a directed graph. In this directed graph, if I tell you this is, then what it means? In directed graph, if I tell you this is, then what it means? Then it means from A to B. And this means, this age means from B to A. But in undirected graph, this basically this AB, this also means between A comma B, and this also means between A comma B. So very simple. So remember, this is only for convenience. We will write like this. Most of the time we will study only undirected graph, and this is important because most of the time we will only study on a simple undirected graph. Almost 99% time, almost 99% time, we will only study simple graphs. We will only study simple graphs. Simple graphs you already know. Simple graphs means undirected, no self loop, no multi edges. This you already know, that it is undirected. It is an undirected graph, no self loop. There should be no self loop, and there should be no multi edges. So this type of graph we will study most of the time. So very simple. Okay. Now let's move on. So these are all the type of graphs you can notice, and all the graphs that we will study, these are simple graph. If I want to teach you something else other than simple graph, if we want to study, then I will mention it. Okay, so all the graphs in these notes are simple graphs unless stated otherwise. So this is the idea. And for notational convenience, this type of age, this type of underrated age, we will denote by AB. This is only for convenience. Very simple. Okay, so now we will take a break, and after the break we will continue. So we will resume in 5 minutes. Hi all. So let's continue. Now let's see some more definitions. Before we see the definitions, let's see this question. The intersection graph. Okay, and in this intersection graph, you have collection of set. These are the vertex. Okay, and you will have as connecting vertices represented to set if they are non-empty. Hello, am I audible? Hi everyone. Yeah, so let's create the intersection graph for this. Assume that no self loops. Assume no self loops. Assume no self loops. So the question is saying that here you have 5 set. These 5 set are vertices because the question is saying a collection of set. This collection of set is the graph that has a vertex for each of these set. So these set are the vertices, and you can notice that an edge connecting the vertices representing two set if these two set are non-empty intersection. If they have non-empty intersection, it means they are not disjoint. Then we will have edge. So tell me, what will be the graph for option A? For option A, what will be the graph? You have A1, you have A2, you have A3, you have A4, you have A5. Now tell me, this A1 will have edge with which? Remember, two set have edge. You have edge connecting two vertices. You have edge which is connecting two set. If and only if their intersection is non-empty, means they are not disjoint. So you can notice A1, A2, they are not disjoint. So there will be edge from between A1, A2. Yes or no? Tell me, this type of graph, will this be directed or undirected? Just tell me this point. This type of graph, will it be directed or undirected? This will be undirected because this is intersection. You know that A intersection B is same as B intersection A. Okay, so this type of graph will be undirected. And in this type of graph, you can notice that if A is connecting to A, if A1 is connecting to A2, then A2 also connect to A1. So because A intersection B is same as B intersection A. And tell me, A1 will be A1 comma A3, will they have any edge? No, they are disjoint. A1 A3 they are disjoint. A1 A4, A1 A4 they are not disjoint. Next, A1 A5 they are not disjoint. A1 A5. Next, what about A2? Start from A2. So A2 A1 we have already seen. Next, A2 A3 not disjoint. A2 A3. A2 A3 these are not disjoint. Next, A2 A4 are they disjoint? Should I put edge between them? A2 A4 should I put edge between them? Tell me. So there should be no edge between A2 A4. What about A2 A5? Yes, there should be edge between A2 A5. Now next, the next is A3. So A3 A4, yes, I should put edge between them. A3 A4. And what about A3 A5? Yes, there should be edge between them. Next, A4 A5, should there be any edge? Yes, there should be edge. So A3 A5 we should put some edge. So this is the answer. This will be your graph. Yes or no? Is this clear to everyone? So in this question, basically these are the vertices. These 5 set, these are the vertices, and between two vertices, this is a vertex, this is a vertex. Between these two vertex, we will have edge if and only if they are not disjoint. Okay, so you can notice A1, A2 are not disjoint, so we have edge. And you can notice A1, A3 are disjoint, so we don't have any edge. And similarly, you can create for this. This I am giving this as a homework. Can you do this? Can I give this question as a homework? So here you have 5 set, total 5 vertices you have, A1, A2, A3, A4, A5, total 5 vertices. Between two vertices, there will be edge if and only if they are not disjoint. Okay, so this is the idea. Now let's move on. Now the next concept is adjacency and degree of a vertex. What is this concept of adjacency? So the concept is actually very simple. If you have, remember, we are discussing only simple graph. All the concepts that we are learning, we are only learning for simple graph. Always remember this. So this concept, like this degree of a vertex, this concept, all these concepts we are learning for simple graph. So let's assume you have a simple graph. Then in simple graph, what is adjacency? So if you have this vertex, and this is your edge. This edge is connecting A, B. So for this edge, I will say what are the endpoints? For this edge, what I will say endpoints of E. For this edge, endpoints are A comma B. These are the endpoints of E. And because these are the endpoints of E, so I can say E is falling on. Can I say E is falling on? Or E is falling on A comma B? Can I say this? E is falling on A comma B. This is E. This is falling on A comma B. This word falling on, this is same as incident on. So this edge is incident on A comma B. Okay. This edge is incident on A comma B. Next, the next thing, because these are connected by a word, because these are connected by A's, this A comma B, because they are connected by A's, so they are adjacent. Okay, you can notice that because A comma B, this is A's, between them you have A's, so A comma B are adjacent. So these two vertices are adjacent. We call them adjacent, or you can call them neighbors, because they are connected by A's. So you can call them neighbors. Is this clear? The definition of adjacent. So because they have edge between them, so any two vertices, if they have edge between them, then they will be called adjacent or they will be called neighbors. For example, if I give you this graph A, B, C, D, then tell me, A comma B, are they adjacent? Are they adjacent or not? This A comma B, are they adjacent? Yes, they are adjacent, because between A comma B we have edge. So yes, they are adjacent. What about A comma C? What about A comma C? These are not adjacent. These are non-adjacent. Next, what about A comma D? Yes, these are adjacent. These are adjacent. And next, what about D comma C? D comma C. What about D comma C? So they are non-adjacent. They are non-adjacent. Okay. What about B comma D? They are non-adjacent. And what about C comma B? They are adjacent. Adjacent or neighbors. I also can call them neighbors. Now tell me, what is neighborhood of B? Like, what is neighborhood of B? Tell me the neighborhood of B. This means neighborhood of B means who are the neighbors of B. So A comma C, these are the neighbors of B. Who are the neighbors of C? So only B is the neighbor of C. So this is called neighborhood. This is something called neighborhood. Okay, so this is the idea of neighborhood. I can say that what is the neighborhood? What is the neighborhood? What is the neighborhood of a vertex? Neighborhood of a vertex is a set of adjacent vertices. That is set of neighbors, I can say. That is set of neighbors. Very simple. So the neighborhood of B, that is A comma C. Neighborhood of C, that is only B. So this is the definition of neighborhood. Okay. So these are the definitions. So we have seen what is edge. If U comma B belong to edge, then we will call them adjacent, or we can call them neighbors. Okay. U is a neighbor of B. And if they don't have any edge between them, then they are non-adjacent or non-connect. Actually, this word I should not use. This connected word I should not use. Okay. After some time, I will tell you that this connected word I should not use. Okay. Anyway, so these are the neighbors. And what is neighborhood of a vertex? That is the set of all neighbors. That is the neighborhood. Okay. So next, what is the incident? Now you can notice if there is edge between U comma V, then we will say that E is falling on U comma V, or I can say E is incident to U comma V. Now the next topic is degree. What is degree of a vertex? What is degree of a vertex? Okay. So what is degree of a vertex? Before we see this degree of a vertex, let me tell you one more thing. Adjacent edges. What is the definition of adjacent edges? We have seen adjacent vertices, but what is the definition of adjacent edges? For example, if I give you this graph A, B, C, D. In this graph, you have total 4 edges. There is E1, there is E2, there is E3, there is E4. So tell me which edges are adjacent? Adjacent edges. Which edges are adjacent here? So can I say E1, E4 are neighbors? E1, E4, can I say they are adjacent or neighbors? Just think about it. Can I say they are adjacent? Yes, they are adjacent because they have a common endpoint. So they are adjacent because they have at least one common endpoint. Okay, they have some common endpoint, some common endpoint. So because they have some common endpoint, so that is the reason I can say that they are adjacent, they are neighbors. Is this clear? But you can notice that E4 comma E2, if you notice E2 comma E4, these are not adjacent. These are non-adjacent. Why these are non-adjacent? Because they don't have any common endpoint. There is no common endpoint. There is no common endpoint. There is no common endpoint because this E2 is basically AD and this E4 is basically BC. Okay, so you can notice there is no common endpoint. This is AD, this is BC. So there is no common endpoint. So this is the definition of adjacent edges. When can you say that two edges are adjacent? Two edges are adjacent if they have some common endpoint. If they have some common endpoint. So I can say E1 comma E4, these are adjacent. E4 comma E3, these are also adjacent because they have some common endpoint. Very simple. Common endpoint. Okay. And here you can notice there is no common endpoint for E1 comma E3. There is no common endpoint. This E1 is simply AB and this E3 is simply CD. So you can notice there is no common endpoint. Now, the next concept is degree of a vertex. What is this degree of a vertex? This degree of a vertex is very simple. If you have a vertex, for example, V, this is your vertex, then like how many neighbors it has, how many neighbors it has, that is the degree of a vertex. So for example, for this vertex, I can say what is the degree of this vertex V? That is 4. So what is degree of a vertex? That is a number of edges incident on it. That is number of edges incident on it. Number of edges incident or falling incident on V, on a vertex. So how many edges are incident on a vertex? That is the degree of a vertex. For example, there are 4 edges here. 4 edges are falling on this V. So this is the degree of V. Is this clear? This is the definition of degree. Now let's see. For example, if I give you a graph, like this type of graph, if I give you A, B, C, D, E, F, G. So tell me, what is the degree of each vertex? What is the degree of each vertex? Find degree. What is the degree? So tell me, what is the degree of vertex B? The degree of vertex B is 2. The degree of vertex B is 2 because there are 2 edges which are falling on B. 2 edges are falling on B. What is the degree of vertex F? There are 2 edges falling on F. There are 2 edges falling on F. Next, what is the degree of E? Degree of E is 2 because there are 2 edges falling on E. Degree of G, that degree of C is 2. Which are falling on D. So this is the idea of degree. Is it clear? Tell me, how many vertices have even degree? Which vertices have even degree vertices? Which are even degree vertices? Which vertices are even degree vertices? Even degree vertices. So you can notice that A is a even degree vertex, B is a even degree vertex, C is a even degree vertex, E, F, these are the even degree vertices. And what are odd degree vertices? Odd degree vertices. So you can notice G comma D, these are the odd degree vertices. G comma D, they have odd degree. So I can say these are the odd degree vertices and these are the even degree vertices. Yes or no? Now one more thing. See, in pseudograph, what you can say? Like if you have a pseudograph, in pseudograph, how to define degree? In this pseudograph, how to define this degree of a vertex, like this degree of V, how to define? Because remember, in pseudograph, you can have self loop. For example, this is your vertex and let's assume there is a self loop. Now, how many edges are incident on A? How many edges are incident on A? Total 2 edges are incident on A, if you notice. Yes or no? Total 2 edges are incident on A, but the degree of A is 3. So in pseudograph, degree is defined like this, that how many times edges are falling on a vertex. So degree of vertex, that will be defined like number of times edges are falling on a vertex. Edges are incident on V. Is this clear? So here degree of A will be 3, degree of B will be 1, because this is falling on A 2 times, this is incident on A 2 times. So I can say degree of a vertex in pseudograph, that will be number of times edges are incident on B. Okay, basically I can say that self loop, if you notice this self loop, this will give you a degree of 2. This will give what this will give, gives a degree of 2. Yes or no? The self loop will give you a degree of 2, because if you have a self loop, for example, this type of self loop you have, then here this self loop is incident on this A 2 times. So this self loop will give you a degree of 2. Actually, you can think like this. This self loop, you can analogy. What is the analogy? The analogy is like this. You can think this self loop like this. Okay, because you can think like this, now you can notice this self loop is giving you a degree of 2 for this A. For this vertex A, this self loop is giving you degree of 2. So this is just an analogy. This self loop, you can think like this. You can think. Is it clear to everyone? Is this clear? Now remember, in simple graph, we don't have self loop. This degree concept is only defined for undirected graph. All these concepts that I'm defining, all these concepts are only defined for undirected graph. Okay, so this concept, like, okay, all these, like these concepts like adjacent, this adjacency concept, this degree concept. So if you notice, these two concepts are only defined. These two concepts are only defined for undirected graph. These are only defined for undirected graphs. Okay, these are not defined for directed graph. For directed graph, we have some other concept like in degree, out degree. Okay, so remember these concepts, adjacency and degree, these concepts are only defined for undirected graph. Is it clear to everyone? For simple graph, what is the definition of degree? For simple graph, there are many definitions of degree you can give for a simple graph. What is the degree of vertex in a simple graph? Because in a simple graph, you don't have any multi-edges. There is no self loop. There is no multi-edges. We don't have any self loop. We don't have any multi-edges. There are no multi-edges. So what is the definition of degree? You can say that is number of neighbors. Can I say number of neighbors? Can I say simply that number of neighbors will be your degree? The degree of vertex, that is number of neighbors. Or I can say that is the cardinality of neighborhood. Means that simply means the cardinality of neighborhood means how many neighbors you have, number of neighbors. Or I can say number of edges incident on vertex V, number of edges incident on V. Okay, so these are the definitions of degree. Is this clear? Neighbors means adjacent. We have already seen these. For example, if you have this graph A, B, C, D, then tell me who are the neighbors of A. Tell me who are the neighbors of A. Who are the neighbors of A? So neighbors of A are B, C, D. Neighborhood. This is the neighborhood. This is the neighborhood. This is the neighborhood. Neighborhood means all the adjacents. Remember, neighbor means adjacent. It simply means this neighbor. This word simply means adjacent. Means how many vertices are adjacent to A. So the neighborhood of A will be BCD. The neighborhood of D, what that will be? That will be ACD. The neighborhood of B, what that will be? Neighborhood of B, that will be A, D. So that is the neighborhood of B. Okay. So I can say degree of a vertex. What is that? That is number of neighbors. Or I can say cardinality of neighborhood of V. Or I can say number of edges incident on V. All these things are same. So that is the definition of a degree. Degree of a vertex in undirected graph. This is only defined for undirected graph. Is the number of edges incident with it. But remember, self loop is counted twice. I can say self loop will contribute twice in the degree of that vertex. Okay, now let's take this example. In this example, find the degree of every vertex. What is the degree of G? Tell me the degree of this vertex G. That is 0, because there is no neighbor of G. There is no neighbor of G. So this vertex has degree 0. This vertex has degree 1. Okay, so this has degree 1, this has degree 0. What is the degree of A? This has degree 2. Degree of F, that will be 4. Degree of E, that will be 3. Degree of C, that will be 4. Degree of B, that will be 4. Okay, so this is the degree of every vertex. How many even degree vertices we have? Tell me number of even degree vertices. I am asking number of even degree vertices. How many vertices have even degree? So you can notice 1, 2, 3, 4, 5. Total 5 vertices have even degree. And what is the number of odd degree vertices? How many vertices have odd degree? So only 2 vertices have odd degree. So number of even degree vertices is 5. Number of odd degree vertices is 2. You can notice this is an even degree vertex. I can say that this vertex B is an even degree vertex. This is an even degree vertex. And if you notice this vertex C, this vertex E is an odd degree vertex. Okay, so very simple. Is this clear? Is this concept degree of a vertex? Now let me tell you that these two concepts, like what is a isolated vertex? What is a isolated vertex? What do you think? What is the definition? Like in this graph, which vertex is isolated? The name itself is telling you isolated. G is isolated. So the definition of isolated vertex means degree 0 vertex. Degree 0 vertex. Any vertex whose degree is 0. So that vertex will be called isolated vertex. Example G. Example this G. This G is your isolated vertex. I can say this is your isolated vertex. And the another definition is pendant vertex. What is a pendant vertex? What is that? The pendant vertex, that is degree 1 vertex. Degree 1 vertex, that will be your pendant vertex. So for example, this vertex D, this is a pendant vertex. Okay, degree 1 vertex will be called pendant vertex. Pendant vertex, that will be degree 1 vertex. And isolated vertex means there is no neighbor. It is isolated, so it has degree 0. The remaining things we will see in the next lecture. In the next lecture, we basically in today's lecture, in this lecture, we have seen the motivation for graph theory, the importance of graph theory. Graph theory is very important. In the GATE exam, you will definitely get almost 5 to 6, maybe 5 to 7 marks of questions you will get from graph theory. Graph theory is very easy and very interesting. You will see. Okay, so all the concepts we will see with the proof, and you will crack GATE exam. You can crack interview. You can crack any other exam like TIFR, NET, ISRO, whatever exam you give, you can crack. Okay. So if anyone has any doubt, you can ask in today's class. Do you have any doubt? And are you finding graph theory interesting? Like graph theory is very important. There is a complete area, research area, graph theory. Okay, this graph theory is a research area. If you go to IISc, IIT, you can do PhD in graph theory. You can do your MTech, MTech research in graph theory. And this is a very interesting field. Any doubt? Do you have any doubt in today's class? Let me know. Is there any doubt? Any concept, any doubt? The concept that we have seen, the definition of graph. Graph is an abstract structure. Remember, graph is just an abstraction. You have a real world scenario. For that real world scenario, graph is just an abstraction. We represent the real world scenario using the graph. These vertices, these are abstraction. These edges, these are abstraction. Okay, so this graph, this is a very simple structure of dots and lines. Lines are connecting dots. Okay, and then we have seen the concept of like type of edges. What are the different type of edges? What are the different type of graph? And then I told you that we will study simple graph. Simple graph we will study most of the time. For simple graph, we have many concepts like adjacent vertices, adjacent edges, degree of a vertex. Okay, so neighbor means adjacent, neighborhood of a vertex. So all these concepts we have seen, isolated vertex, pendant vertex. So this is the complete summary of today's lecture. If anyone has any doubt, you can ask. Okay, so Abhipsa is asking, sir, adjacency edges will have only one vertex in common. See, for simple graph, this will happen. Yes or no? If you notice, for simple graph, actually, most of the time we will study simple graph. So, Abhipsa, this definition that we are looking at, all these definitions, they apply only for simple graph. For simple graph, yes, you can only have one common endpoint. You cannot have more than one common endpoint. See, two edges, just tell me, is it possible that two edges can have same endpoint in a simple graph? In a simple graph, because I told you that all these concepts we only study for simple graph. Many of these concepts are not defined for other type of graph. Okay, so for simple graph, these concepts are defined, like degree. This degree concept is defined for undirected graph. This is not defined for directed graph. Similarly, adjacency, neighborhood, these concepts are defined for undirected graph. Okay, now in simple graph, is it possible that two edges can have same endpoint, like both the endpoints are same? You cannot have. Yes, simple graph doesn't have multi edges, right? So that's the point. So you can never have two different edges, can never have both endpoints same. So what this means? This means that in these two edges, can never have uh, both end like can never have both endpoints common. Okay, so you can notice, like, this type of thing is not allowed in a simple graph. So I can say this E1 and this E2, these are adjacent. C, D. So you can notice that this E1 comma E2, these are adjacent. But you can notice that this E3 and this E2, these are not adjacent because they don't have anything common. Any other doubt? In simple graph, we do not have multi edges. In simple graph, we do not have self loops. Okay, there is no self loop, there is no multi edges in simple graph. Any other doubt? Anyone? Is there any other doubt? Okay, see you tomorrow. Thank you.